All right, so this one says, find the measure of each interior angle of Pentagon Abcde. So since it's a pentagon, that means we know that n equals what? 5. All right. So to find the two problems that we did right before this, we found each interior angle, and which one is it? Yes, you do. Are you that afraid of me? Okay. On the two questions before this, we just found the total number of degrees and divided by the number of angles. Why can't we do that on this one? The angles are not all the same because this is not a what kind of polygon? It's not a regular polygon, and it's also not 180. Okay, the way we have to do it, we may know exactly what it is, but it's not 180 because it's not a triangle, right? And I know that we already found it in this problem anyway. Plus, it's on the page before that. But when you come across a problem like this, you may not just know what the total number of degrees is, or have had it on a problem above it or before it. So we're just going to start from scratch. And I know you already have this written down, but it's okay. So n equals 5. I need the total number of degrees, or my magic number for a pentagon. So that's what I'm going to do. N minus 2 times 180. So 5 minus 2 times 180. That's the 3 times 180, and that's where I get 540. So that's my magic number for pentagons. Okay? Yes? Why minus 2? Because that is the formula that we came up with yesterday. So you might want to go watch the video from yesterday now. So that's my magic number. Now, this is why I don't mind repeating myself on this, because some of y'all need to hear this again, especially those of you that are hard-headed. The process way more important than the answer, and some of you lost points on your final exam for this very thing. This is not a difficult problem. Okay, I need to add all those up and try and figure it out from there, but I don't care if you can add it in your head or not. That doesn't impress anybody. If you're supposed to add those all up and set them equal to the total, you have to physically do that and write that down. That is something that you're looking for. I did not write that final exam. I did not write the rubric to grade it. However, I was fine with it because the rubric was actually decent, and points were taken off for stuff like that. So when I tell y'all that you have to do this stuff, it's not because I think you should, and it's not because it's my pet peeve. It's because that is the process that is going to be graded on anything you do going forward. So I need to add all those up. So I'm going to do that. I'm going to get 35C plus 18C plus 32C plus 32C plus 18C. And all that equals what? 540. Does it also equal 135C? Yeah, and if I put that there, it's a true statement. Is it going to get me anywhere? No. That's why first step, zero work. You substitute everything in. That is your setup. That right there, way more important than any other step in here, including the answer. Okay? Now, past that, you skip steps, whatever. So I add all those up. I do get 135C equals 540. So then I know you have a calculator in front of you right now, but don't touch it. Plus you already have the answers, or you should if you weren't over here trying to high-five people at the beginning. While you're up, will you grab an extra one and give it to Katya, please? Just give her one of the high numbers so she has one. You, for yourself, need to learn to release that calculator a little bit more than you do on your own. I mean, I force you to do that sometimes, but if you are not practicing that way, it's not doing you any good. Because if every time you leave here, I know when y'all leave here you're using them, I'm not stupid. Even when I tell you you shouldn't, I know some of you still are, and not necessarily everybody all the time. But if that's what you do, and then the only time you truly don't use one is when you truly don't have one in front of you and I don't allow you to, then you're just going to struggle with that even more, right? So you have it there as a resource and maybe to check yourself, but not so much as a crutch as it is for so many of you. So yeah, I could just divide this, but if I'm going to not have a calculator here, long division's not the best thing here because that really just turns into guessing and checking for a problem like this. And it may come out nicely if you can guess and check with the first thing that you get, and especially if it divides evenly, you're more likely to guess the right thing. But when it doesn't divide evenly, then it just becomes a whole lot of crazy mess all over the place. So what this is 540 divided by 135. And then don't spend any time trying to figure out the biggest number, right? Those are clearly both divisible by 5. So 5 goes into 5 once, goes into 4 0 times, and you have 40, so that's 108. 5 goes into 13 twice with 3 left over, so that's 7. All right, so then 108 and 27, those are both divisible by what? 9 and 3, okay? So we know the 3 trick, right? We've talked about that a few times. Do we know the 9 trick? It's the same as the 3 trick. If you add 1 and 8, you get 9. You add 2 and 7, you get 9. Those are both divisible by 9, so these are divisible by 9. It only works for 3 and 9, okay? Don't try on 7 and 13 and anything else, okay? It only works on 3 and 9. So that means that 9 goes into 10 once with 2 left over, so that's 12. 9 goes into 27 3 times. Can I reduce even more? Yeah, the answer in the end is 4. Okay, but that process starts to go a little quicker when you're actually used to doing it and you're not freaking out because you don't have a calculator in front of you. All right, so then am I done? Is that my final answer? No, because I want the measure of each angle. So I have to come back over here and substitute it in. So 35 times 4. Now remember, multiplying by 4 is like multiplying by 2 and then what? By 2 again. So 2 times 35 is 70 times 2 is 140. All right, 18 times 4, so it's 18 times 2 is 36 times 2 is 72. Okay, and look, that one's 72 also. So then 32 times 4, so 32 times 2 is 128. Now, as you get to this, we're still not done because we found all of our answers, but have we actually answered the question? No, because you just labeling it on the picture, unless that's what it specifically tells you what to do, you still didn't answer the question. You also don't have to list out 5 angles necessarily. And I know I didn't, especially since I didn't give you a whole lot of room on here to write any of this. Just kind of do the best we can here. So let's see, the measure of angle A is 140 degrees. The measure of angle E, all right, it is equal to 72, but it's also equal to the measure of angle B, which is equal to 72, and that allows you to not have to list them all out. It's fine if you list them all out separately, but this kind of thing is okay too. Measure of angle C is equal to 128. Oh, well, all right, I didn't mean to do that, but it's also equal to the measure of angle D. So I can do it like that even. I didn't really intend to do it like that, but wrote the number down first, so that's fine, because you do have them all answered there, and then this really is my final answer. I don't think, I know that you know how to work a problem like that. It's more that before yesterday you wouldn't have known to use 540 or how to find it, and then also I need to reiterate process. Process, process, process. Okay, we good? Questions? All right, so now we're going to look at exterior angles. So let's talk about what an exterior angle is first. So here we have a triangle. If I extend this side length right here, it creates an exterior angle right here. Does that make sense? And you don't extend both of them. For instance, don't do this because I'm going to erase it. But if I extend this one right here, then I end up with these other angles here. Now, whether this is my exterior angle or this is my exterior angle, as long as I just extend one of the sides, it's fine. Because are these two angles congruent? Yeah, what type of angle pair is that? Vertical angles. And then this one isn't, I know it's on the outside, but it's not the exterior angle of the polygon because one of the sides has to be. So it doesn't matter which one, but you definitely wouldn't use them both. All right, so that's what an exterior angle is. If I have 3 sides and 3 interior angles, then I have 3 exterior angles. However many, everything else it has, that's how many exterior angles it has. So I want you just for the triangle. You can use your calculator, even though I know you don't necessarily need it, but it does help. And add these 3 numbers up for me to get the sum of the exterior angles of this triangle. You get 360. Okay, then just stop right there. All right, so since the sum of the exterior angles in that triangle is 360, what do you think for any polygon the relationship might be between the sum of the interior and the sum of the exterior? The same. Get out of my classroom. Be done. Maybe because it looks like maybe it would be double, right? I mean, that's a conclusion we could draw, right? All right, so inductive reasoning is the type of reasoning we're using right here. And with inductive reasoning, it's a conclusion you draw based on a pattern of events, right? And the more of those events that you have, the more accurate your conclusion could be. So let's say that we were just going to do a pattern of numbers. I'm going to give you like a list of numbers. And I say, okay, the first 2 numbers are 2, 4, and then what do you think the third one might be? 6? And then what do you think the next one might be? then 8. So maybe 2, 4, 6, 8. Would everybody would that make sense? It could be 2, 4, 8. Because what if my rule isn't counting by 2s, but my rule is doubling the number before it, right? So if I just give you 2 and 4, you don't really know where to go, or maybe there's more than one answer, right? But if I give you like 10 of them in the pattern, there's really probably only one other thing that could come next, because you could figure out it more conclusively, right? So that's a good idea of maybe what's happening. So now I want you to look at this. What shape is this? Pentagon. Okay, so I want you to add up the exterior angles in this pentagon. And don't yell anything out. Let everybody. Does it seem kind of weird? Yeah? All right. So, Tony, what'd you get? You got 360. The rest of y'all get 360? Yes. Is that what you expected to get? No, yes, maybe. Maybe not, because how many interior degrees are in a pentagon? That's how many angles. What's the sum of the interior angles? 540, okay. 540. So we thought, well, maybe it's double. So if this was 540, then that maybe it would be like 1080, but it's not, right? Okay. That's a good thing that I'm going to show you at the end. So kind of, yes. So this is 360, right? And which for some people it makes sense, but for some people it just seems weird because you're getting more and more exterior angles, right? But what's also happening to those angles? They're getting smaller, yeah, because the interior ones get bigger, so the exterior ones get smaller and smaller, but we're getting more and more of them, so it's not like it's really changing that much. So really, you would think maybe this would get smaller instead of get bigger or even stay the same, but it ends up staying the same. It kind of equals out. We're getting more angles, but the angles are getting smaller, and that sum ends up staying right there at 360. I'll show you a little animation at the end that kind of explains what Xavier was getting at there. But for the interior, the degrees change. The sum of the interior angles, that totally changes. For the exterior, it's 360 no matter what type of polygon it is. If it's a 25 gon, the sum of the exterior angles, 360 degrees, okay, for every single one of them. There's not a little equation like n minus 2 times 180. It just is 360. So your polygon exterior angle sum theorem says the sum of the exterior angle measures, and then it says one angle at each vertex. That means you're only extending one side. Like I showed you a minute ago, you wouldn't count all three of them or whatever, just one of them. And it has to be a convex polygon, is 360 degrees. That's an easy question. Don't miss it. When like on a test question, it just says, what's the sum of the exterior angles of a dodecagon? 360. There's not even any work. Like that is what it is. Okay. All right. So let's look at this question here. It says find the measure of each. Okay, you still have to read these carefully because these questions look a lot like the ones that were on that other page. Yes, sir. Oh, yeah. Oh, yeah, but okay, I think you're saying like do it this way? Okay, but yeah, so if I did that, then this is 110 and so is that. So even though it is more angles, I'm only actually using one at each vertex, but whichever way I extended it, I would get the same angle measure either way. Does that make sense? It does make more angles, but this is when we are only counting only one at each vertex, regardless of which one you might draw. Does that make sense? That's a good question. All right, but you still want to pay attention to these little words because it's easy to do the wrong thing or not enough. I want each, and we're talking about exterior angles, and this is a regular hexagon. So if it's a hexagon, n equals what? 6. So that means it has 6 interior angles, 6 exterior angles. And what do you know about the angles in this hexagon in particular? They're congruent, okay? And that's the interior angles, right? Do you think the exterior angles would be congruent as well? Yes, because if you're going to extend off the same measure of the angle all the way around, then yeah. So that means that if you want each interior or each exterior angle and it's a regular hexagon or a regular anything, it's just 360 divided by the number of sides. So in this case, it's 360 divided by 6, which gives you what? 60. So this is each exterior angle. Now, I want you to think about this. I'm going to draw a hexagon. You're going to have to pretend like it's regular because it's not going to look regular. But if I draw this, no, it's really not. I started off okay, but then it just kind of went to crap. But that's okay. So what we have found here is that the exterior angle is, each one of them is 60 degrees, right? Okay. So this exterior angle is related to this interior angle. How? They are a linear pair, which means that those two angles are also what? Supplementary. So if this is 60 degrees, what's the measure of this angle? 120. So the measure of each interior angle for a regular hexagon is 120. So yesterday we did n minus 2 times 180 and divided, right? Which is fine, that's one way to do it. But it's actually a little bit easier to get to that point using the exterior angles because you don't have to, the numbers aren't as big, you don't have to do the n minus 2 and things like that. So as long as you understand how to relate them and you can show how you got it and you just don't have numbers written down, using the exterior angles to come up with the interior angles is totally okay. And this, just like anything else, the more tools you have in your toolbox and you understand their relationship with each other, then you can choose what's the best way to do it at which time. Okay, but if you're only, you look at your notes, you do it because it matches, and you're just like a robot just trying to match it up with something else, and you never understand why you're doing anything, then you're never going to get it. But when you understand how the different pieces work together, then you can go about them different ways. Okay, we all good so far? All right, so that's, look at this one. It says find the measure of each exterior angle, regular dodecagon. Dodecagon n equals what? 12. So this is going to give me 360 divided by 12, which is 30. Okay, and that is each exterior angle. Which means then also, it doesn't ask you that here, but the measure of each interior angle would have to equal what? 150. I know it only asks for exterior, and you don't have to always go find the other, but do you see how easy that makes that? Okay, and the numbers end up being a little bit smaller sometimes. Any questions at all? All right, so on C, it says to find the value of A in polygon RSTV. So these angles that are labeled are what kind of angles? Exterior. So I'm going to add them all up and set them equal to the sum of the exterior angles. So how do I find the sum of the exterior angles of a pentagon? Is it 360? 540? What is it? How do I find the sum of the exterior angles? It's 360. I don't have to find it. It's 360. Okay? So don't go do anything weird trying to find the sum, because the sum is 360. If it's exterior, the sum is 360, whether it's a regular polygon or not, and no matter how many sides there are. So I approach this the same way I do it the first one at the top up here, is I got to add them all up and set them equal to whatever that sum is. So I've got 2a plus 7a plus 2a plus 3a plus 6a equals what? 360. And remember, when you have to write down a lot of stuff like this, you might want to count to make sure you used them all and didn't use one twice or something. All right, so when I add them up, how many a's is that? 20. So I get 20a equals 360. So a equals 360 over 20. So what can I knock out easily there? 2. The 0, yeah, I knocked the zeros out first, yeah. And then divide by 2, and you get that a equals what? 18. It's okay. But split it up. Half of 30 is 15, half of 6 is 3, and that's your 18. All right, so then do I have to come over here and substitute it in? It says find A. I found A. I am done. Okay? We good? Any questions? All right, then this last one says the aperture of the camera is formed by 10 blades. All right, so let's just talk about and I know that your picture is probably hard to see. Mine is almost impossible, and it doesn't copy well no matter what I do, but it's okay. I'm going to make sure that you understand what it is in just a minute. Aperture of a camera. So like the camera that's on your phone doesn't even have a cover, and a lot of cameras just have one that'll just pop on the front. But to either like take a picture or even close the lens, in some cameras there's like these plastic blades that overlap each other and come together. Do you know what I'm talking about? And somebody said it's like the beginning of a James Bond movie. It is, because that's what it is. It's like a camera. But that's what a camera aperture is. So it says the aperture of the camera is formed by 10 blades. This one is. It can be formed by less than 10, but this one in particular is 10. And it says the blades overlap to form a regular decagon. So I'm going to use the camera aperture. I've got a little animation I want to show you that kind of explains what Xavier was saying about it going around in a circle and then being the exterior angles. So I have to, in order to be able to see it, I have to completely turn the lights off because it just looks like a black blob up here. All right, so let your eyes adjust for just a second. So do you see how these are like the plastic blades, right? And then this would be like, it's closed a little bit. I've already closed it a little bit. But I think this one, I think it said decagon. I think this, how many does this one have? This is an octagon. So they don't all have 10. This one had 10. This one has 8, whatever. But, and these curve a little bit. But if they didn't, if they went out straight, do you see how it creates all these little exterior angles out here? Okay? And whether I have 8 or whether I have 10, whatever, when it's all the way open, you know, it looks like this. And then as it closes and my octagon gets smaller and smaller and smaller, the vertices of that polygon, no matter how many sides it has, all converge on one point. Okay? So this one point here is like the vertex of all of those angles now. And because it does create, I can draw a circle around it, these angles have to add to give me what? 360 every time, no matter how many there are. The more of them there are, the smaller they are so that they all fit in there. But even if I had a 1,000-sided polygon, I'd have 1,000 little tiny angles there and they'd all add up to give me 360. Yes, sir. Yeah, this is an iPhone camera aperture. It's the only it's the best animation I could find that I could actually control and do it. But yeah, it is the old. But so does that make sense? You see how that works? It's not really an explanation as to why, but it does kind of make it make a little bit more sense, I think, to you. I don't know. It just like, I think it opens and, yeah, it closes and then it opens back up. It's just a little fast to kind of focus on what's going on. All right, so this is what your picture looked like before it got copied. And I know that, like I said, I know you can't hardly even see it. But it says, what is the measure of angle CBD? So CBD is this angle right here. It's one of the exterior angles. Right? Just looking for that one. So what's the sum of all of those angles? 360. So 360, and in this one it would be divided by what? 10. Okay? So then that would just give me 36 degrees. That's the measure of angle CBD. I'll turn it back on so you can see what the heck you're writing. All right. Any questions at all? Say that one more time. It's just the point that's on it's a point that's on that ray right there. Yeah, it's the white one. I know it's hard to see. And I know it's really hard to see on what you have. But I've tried reshading it and doing all kinds of things. Just didn't work out well. All right, any questions? We good? Yes? All right. So go ahead and glue those in.